Overloaded circuits may be the issue. The current draw of 38 amps on both legs may be exceeding the capacity of the 100 amp breaker. Another possibility is conductor damage. The 4 American wire gauge or 2 American wire gauge aluminum conductors may be damaged, causing increased resistance and heat buildup. Loose connections could also be a factor. Despite tightening connections, there may still be loose or corroded contacts creating resistance and heat. Panel bus issues are another consideration. Discoloration in the bus bar indicates possible overheating due to loose connections or high current draw. Breaker failure is another possibility. The breaker may be defective and not tripping at its rated capacity. To address this, verify the circuit load. Determine the actual current draw of the 2 alternating current units using a clamp meter. Ensure that the load does not exceed 80% of the breaker's rating, which is 80 amps for a 100 amp breaker. Inspect the conductors. Examine the conductors for any damage, such as cuts, kinks, or corrosion. If damage is found, replace the affected section. Tighten the connections. Double-check all connections, including the panel terminals, disconnect switches, and alternating current units. Use a torque wrench to ensure proper tightening. Inspect the panel bus. If discoloration is significant, consider replacing the bus bar. Loose connections or high current draw may have caused damage. Test the breaker. Use a breaker analyzer or other tester to verify the breaker's functionality and trip characteristics. Replace the breaker if it is found to be defective. Separate the circuits. Run separate copper feeders to one of the disconnects and use 250 amp breakers in the panel. This will reduce the current draw on each circuit. Additional tips include: firstly, use antioxidant compound on all aluminum connections. Secondly, protect the copper feeders from direct sunlight, as this can cause degradation. And thirdly, regularly maintain the alternating current units to ensure they are operating efficiently. A deeper dive into each of these steps can help identify and resolve the problem. Let's begin with verifying the circuit load. It's essential to accurately measure the current draw of each alternating current unit. Use a clamp meter to measure the amperage on each leg of the circuit while the units are running under normal operating conditions. Add these measurements together to determine the total current draw. Remember that the total load should not exceed 80 amps for a 100 amp breaker. If the current draw is consistently above this threshold, the circuit is overloaded. To resolve an overload situation, consider the following steps. Firstly, reduce the load on the circuit by identifying any unnecessary appliances or equipment connected to it. Secondly, consider upgrading the breaker and wiring to a higher capacity, ensuring that the panel and service entrance can handle the increased load. Thirdly, as suggested, separate the alternating current units onto separate circuits with their own breakers. This will distribute the load and prevent the 100 amp breaker from tripping. Next, inspect the conductors thoroughly. Aluminum conductors are known to be more susceptible to corrosion and damage than copper conductors. Carefully examine the entire length of the conductors for any signs of damage, such as cuts, kinks, corrosion, or discoloration. Pay close attention to the areas where the conductors are connected to terminals, as these are common points of failure. If you find any damaged sections, replace them immediately. When replacing aluminum conductors, it's crucial to use connectors and terminals that are specifically designed for use with aluminum. These connectors are typically made of aluminum alloy and are coated with an antioxidant compound to prevent corrosion. It is also important to torque the connections to the manufacturer's specifications to ensure a secure and reliable connection. Now let's talk about tightening connections. Loose connections are a major cause of overheating and breaker tripping. Even if you have already tightened the connections, it's worth double-checking them to ensure that they are secure. Use a torque wrench to tighten the connections to the manufacturer's specifications. This will ensure that the connections are tight enough to provide good electrical contact, but not so tight that they damage the terminals or conductors. Pay close attention to the connections at the panel terminals, disconnect switches, and alternating current units. Make sure that the wires are properly inserted into the terminals and that the screws are tightened securely. If you find any corroded or damaged terminals, replace them immediately. Moving on to inspecting the panel bus, The bus bar is the main distribution point for electricity in the panel. It is essential to ensure that the bus bar is in good condition and that all connections to it are tight and secure. Look for any signs of discoloration, corrosion, or damage to the bus bar. Discoloration can indicate overheating, which can be caused by loose connections or high current draw. If the discoloration is significant, consider replacing the bus bar. Replacing a bus bar is a complex and potentially dangerous task that should only be performed by a qualified electrician. It involves disconnecting all of the circuits connected to the panel and removing the old bus bar. The new bus bar must be installed correctly and all connections must be tightened to the manufacturer's specifications. Remember to de-energize the circuit before doing any kind of electrical work. Next, test the breaker. A breaker can fail over time, causing it to trip prematurely or to not trip at all. It is essential to test the breaker to ensure that it is functioning properly. A breaker analyzer is a specialized tool that can be used to test the trip characteristics of a breaker. It can measure the amount of current required to trip the breaker and the time it takes for the breaker to trip. If the breaker is not tripping at its rated capacity, or if it is tripping too quickly or too slowly, it should be replaced. If you don't have access to a breaker analyzer, you can perform a simple test using a known load. Connect a load that draws approximately 80% of the breaker's rating to the circuit. If the breaker trips immediately or within a short period of time, it is likely defective and should be replaced. Now let's discuss separating the circuits. As previously mentioned, separating the alternating current units onto separate circuits with their own breakers is a good way to reduce the current draw on each circuit and prevent the 100 amp breaker from tripping. This involves running separate copper feeders from the panel to each of the disconnect. The copper feeders should be sized appropriately for the load that they will be carrying. For example, if each alternating current unit draws 25 amps, you would need to use conductors that are rated for at least 30 amps. It is also important to install separate 50 amp breakers in the panel for each circuit. When running new conductors, be sure to follow all applicable electrical codes and regulations. This includes using the correct type of wire, properly supporting the conductors, and making secure connections. Finally, let's review some additional tips. Firstly, use antioxidant compound on all aluminum connections. Antioxidant compound helps to prevent corrosion and ensures a good electrical connection. Apply a thin layer of antioxidant compound to the conductors and terminals before making the connections. Secondly, protect the copper feeders from direct sunlight, as this can cause degradation. Direct sunlight can damage the insulation on the conductors and cause them to become brittle and crack. This can lead to shorts and other electrical problems. Protect the conductors by running them in conduit or by using a sunlight-resistant type of wire. Thirdly, regularly maintain the alternating current units to ensure they are operating efficiently. A poorly maintained alternating current unit can draw more current than it should, which can overload the circuit and cause the breaker to trip. Regularly clean the coils and filters and have a qualified technician inspect the unit annually. By following these steps, you can troubleshoot and resolve a 100 amp breaker tripping due to overloaded alternating current circuits. Remember to always prioritize safety and to consult with a qualified electrician if you are not comfortable performing any of these tasks yourself. In summary, a systematic approach to troubleshooting involves identifying the potential causes, performing thorough inspections, testing components, and implementing appropriate solutions. The key is to address each potential issue methodically and to ensure that all work is performed safely and in accordance with electrical codes and regulations. Understanding the fundamentals of electrical circuits and the characteristics of different types of conductors and breakers is essential for effective troubleshooting. Additionally, having the right tools and equipment, such as a clamp meter, torque wrench, and breaker analyzer, can greatly simplify the process. Finally, never underestimate the importance of regular maintenance and preventative measures. By keeping your electrical system in good condition and addressing any potential problems early on, you can prevent future issues and ensure the safety and reliability of your electrical service. Consider the age of the installation as well. 12 to 15 years may have resulted in component degradation. For instance, the alternating current units themselves might be drawing more current as their components age and become less efficient. Similarly, the disconnect switches located near the alternating current units could have experienced wear and tear over time, leading to increased resistance at the connection points. A comprehensive assessment should take these factors into account. Also, consider environmental factors. The location of the equipment outdoors exposes it to various weather conditions, including temperature fluctuations, humidity, and precipitation. These factors can accelerate corrosion and degradation of electrical components, particularly at connection points. Therefore, it's essential to inspect the connections for signs of corrosion and to ensure that they are properly protected from the elements. The suggestion to run new copper feeders and separate the circuits is a proactive approach that addresses the potential for overloading and improves the overall reliability of the system. Copper conductors are generally more resistant to corrosion and have better conductivity than aluminum conductors, making them a preferred choice for critical applications. However, it's important to ensure that the copper conductors are properly sized for the load and that all connections are made with compatible connectors and terminals. Furthermore, consider the possibility of harmonic distortion in the electrical system. Harmonic distortion can be caused by nonlinear loads, such as electronic devices and some types of alternating current units. Harmonic currents can flow in the neutral conductor and can cause overheating of the breaker and other electrical components. If harmonic distortion is suspected, it may be necessary to install harmonic filters to mitigate the problem. Finally, it is crucial to document all findings and actions taken during the troubleshooting process. This documentation can be valuable for future reference and can help to identify any recurring problems. Include details such as the measurements taken, the components inspected, the repairs made, and the dates of the work performed. In conclusion, troubleshooting a breaker tripping issue requires a systematic and comprehensive approach. By considering all of the potential causes, performing thorough inspections, and implementing appropriate solutions, you can effectively resolve the problem and ensure the safe and reliable operation of the electrical system. Remember to always prioritize safety and to consult with a qualified electrician if you are not comfortable performing any of these tasks yourself.